Today we're going to talk about different forms of both these polynomial and rational functions. So polynomials, right? We looked at those before, and we looked at them here in factored form and also in standard form. Rationals can be the same thing. We can factor them, or we can see them in general form, as it's called. So this first one, example 1, find the degree of this polynomial. Well, our degree is 3, right? That highest power. So what is the end behavior? We know it's a bendy straw going up. So as that would be, so the limit of f of x as x goes to infinity, it's going up. And the limit of f of x as x goes to negative infinity, it's going down. So our y-intercept, if we plug in a 0 for x, we'd have 2 times 0 cubed minus 16 times 0 squared plus 32 times 0, so that's at 0. To find the zeros, our x-intercepts, we have to factor it. So all of these I can pull out in x. So you have 2x squared minus 16x plus 32. Well, actually, I could divide all those and divide out a 2x out of all of them. So if I take out a 2x, x squared minus 8x plus 16. And now I could factor this into x minus 4 and x minus 4. So I know there's a 0 at x equals 0 and x equals 4. So the question is, when is this greater than 0? Well, I know it crosses at 0, 1, 2, 3, 4. And it bounces, right? Because that is a multiplicity of 2. So I know it comes up, comes back down, bounces, and hits it. So where is it greater than or equal to 0? From 0 to infinity. So now this one, our domain, all right? Well, we know x can't be in the denominator, so x can't be negative 3 or 1. So I know it can't be negative 3 and x can't be 1. So our domain would go from negative infinity to negative 3. There's that break. Negative 3 to 1, another break, and 1 to infinity. Are there any zeros? Well, when does our numerator equal 0? So at x equals 0 and x equals 5. Are there any wholes? No. Verticals at x equals negative 3 and x equals 1. Horizontal. So if we look at our degrees, this is 3x squared over x squared. So as x gets really, really big, it's going to go to 3, so y equals 3. And our y-intercept, if we plug in 0, so that's 0 on top, or negative 3, so our y-intercept is 0. Now, so again, different ways of writing things. So one we're going to try to take a look at is how do we factor something here. So when something gets really, really big, we don't want to write it out all the time. So there's something called Pascal's triangle. All right, so if you can see the pattern, to get the next number, you add the two top ones. So 1 starts with a 1, 1 plus 4 is 5. 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and 1. So what happens if you didn't want to multiply this out? One thing you could do is you look at the second row of Pascal's triangle, 1, 2, and 1. Next to all of these, you write the terms, okay? And then this first one, you start at 2, 1, and 0. And this one you go 0, 1, and 2. So this ends up being anything to the 0 power is 1, x squared, 2 times 5, 10x to the first. That's 1, 25. So this multiplies out to x squared plus 10x plus 25. So it's kind of a shortcut for multiplying some of this out. So like the third row, you could write this out 3 times. Or I could take this third row, and then again I write the terms, so x, 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 and x, 5, 5, 5, and 5. This one, we start at the highest power, 0, 1, 2, 3. So this ends up being x to the third. 5 times 3 is 15x squared. 5 times 2 is 25 times 3, 75x. 5 to the third is 125. So this multiplies out to x cubed plus 15x squared plus 75x plus 125. All right, so if we needed to do to the fifth power, again, I write out the fifth row. X, 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 negative 3. And you'll notice I put that negative 3 in parentheses. All right, then we start the highest power, 5, 4, 3, 2, 1, 0. 0, 1, 2, 3, 4, 5. So this just is x to the fifth. Negative 3 times 5, negative 15x to the fourth. Negative 3 squared is 9, so 90x cubed. Negative 3 cubed, negative 27 times 10. Let's see, so that would be 81, negative 81 times 5. So negative 405x, and negative 3 to the fifth. Oh, geez, so 81 times 3, so negative 243. So this is x to the fifth minus 15x to the fourth, 90x cubed minus 270x squared minus 405x minus 243. So this one has to find the third term. So we got to do the sixth row. So 1, 6, 15, 20, 15, 6, and 1. And now you'll notice I have to put 2x and a 3. Now I only need the third term, so I'm going to stop there because this would go 0, 1, 2. This one would go 6, 5, 4. So this is the term we need. So I need 15 times 2 squared, x squared, times 3 to the fourth. And I don't have a calculator on me, so 15 times 4 is 60. 3 to the fourth is 81. We'll see if I can do this. 6. So we would have 4,860 x squared. So that's our binomial theorem there, and it just talks about the expansion here with Pascal's triangle.